All right, let's start with a brand new project here. And this time we're gonna go ahead and import an actual external asset. And it's a 3D object through a GLTF file, that's what it's called. And we are going to go ahead and use scroll trigger with Greenstock Animation Platform to move this object around in 3D space based on scroll. So this is a very popular use case, and there's many different ways that you could take it, and it really just unlocks a lot of creative possibilities. So I am in 100%, as you can see, blank folder right here. It's just called before. And I'm gonna go to the terminal down here, and let me make sure that you all can actually see what I am doing. Okay, there I can see myself on screen right now on my other monitor. And what we're gonna do is we're gonna type in get clone. I'm mixing up my commands here. This URL right here. It's what we did. It's the Three.js starter that we've been using, and I'm gonna put it in a folder. I think we'll just call this, well, let's just call it before. So there's gonna be two folders called before, unfortunately, inside of each other. So then I'm just gonna go ahead and just open the same folder here. If I go back to the right area, there we go, threes, before, there we go, okay. And now we have this opened up. So what I wanna do is install a few dependencies first that I know we're gonna need for this particular project. So we're gonna go ahead to new terminal here, and we're going to specify, let's see here, let's put Control B. Oops, sorry, can only do that over here. Control B, there we go. We're gonna specify to install npm I. It's gonna be, we need GSAP, all right? We also need Linus as well. And so to install Linus, it's going to be, I believe, this. Alrighty, so it's at studio-freight/Linus. You can see that the command right here. Okay, had to move out of the way there. All right, so now if we go back to look at the folders package.json, we should see Studio Freight Linus, yep, right there, and then our GSAP as well. Now we can go ahead and put npm I just to install all the other dependencies that were present in our package.json. Oh, actually, I think running that as well ran that already. So never mind, sorry, I was being a little bit slow. I'm a little bit slow today, sorry about that. So we have index.html, we have our script.js, and let's go ahead and import a few of the things that I know we're gonna need. So import GSAP from GSAP, there we go. We have access to Greenstock Animation Platform. We're also going to import the scroll trigger from GSAP /scroll trigger right there. And then finally, we're also going to import Linus, which is the smooth scroll library. And I think for our particular effect, it's gonna be a scrub animation. Having a smooth scroll when you're utilizing scrub animation just makes it flow nicer in terms of the animation. So we're gonna do at studio freight /Linus. Great. So now we have these three imports ready to rock. And let's go ahead also run npm run dev as well, so we can get our server up with the preview of what's happening. Okay, so again, we just have like this black background. One of the things that we're going to do is, and one of them is going to be a new thing, we're going to specify, like we did before, alpha true. And we're also going to specify another property that we haven't yet used, and that's for enabling anti-aliasing. And I'll try to remember to toggle this on from true to false, just to try to show you the difference in what happens when it's just false. By default, it's not true. So anti-alias, we're gonna set that to true. And we might not even be able to see it right here. So before I hit save, it might be hard, very hard to see. If I zoom up, you can see this little anti-aliasing. It's like little jagged, sharp edges. And again, it may not come through because, you know, I'm working with video quality, but you might be able to see it on your own end. And if you want to get rid of that and make that smooth, you specify anti-alias true. All right, so when we save it, we get rid of that background, but now you really don't see many of those jagged edges too much. Okay, So now what we're going to do is let's change gears and let's do something we haven't yet done before, and that is import our own 3D model. Now, there's a bunch of places online to get free 3D models. There's even an AI service that will generate 3D models based on prompts, which is pretty crazy if you think about it. So I'm just going to show you one area where we can get free 3D models, and then we're going to get a model imported into here. So if you go to market.pmnd.rs, this URL right here, you're going to see this right here, this all model section. And there's just a ton of different random models, 3D models that you can potentially use in your project. So I looked through this and I found one that I thought would be cool to use, and it's a target or a bullseye essentially. So if I click on this, you'll see it just gives you some stats. You can move it around. They're actually using, for you to preview this stuff, Three.js. In fact, you can tell if you go over to this Wappleizer area, which for some reason it's not loading. There it goes. You'll see it's using, that's interesting. I don't even see it there. I saw it yesterday. But anyhow, what we want to do is I download this. Now, sometimes, depending on which model, like if you try to look at some other ones, it'll tell you if there's any other type of special compression requirements, like the Draco compression. If you do that and you try to import it, you're going to have to also import it this Draco loader, Draco or whatever. But this one doesn't require it, so it's a lot more straightforward. Okay, so let's click download model, and when you do that up here, it'll show you have the model here. And what you want to do is import that model into the static folder, and it's a GLTF file. So on my other screen, I'm going to open up, let's see here, my folder. And one second, it's going a little bit slow here, so let me try that again. Click on it. There we go. All right, so I'm going to simply just drag this over here into static. I'm going to rename, and we're going to call this bullseye. All right. And the first step to getting this imported is we need to import what's called a GLTF loader. All right, so we'll do that up here, and we're just going to import GLTF loader from 3.example/examples JSM loaders GLTF loader.js. Okay, so once we have that, we can now create an instance of it. Const loader equals new GLTF loader, just like that. And we're also going to register the GSAP plugin. I'll do that here while we're here at this point in time, even though we don't need it just yet. There we go. All right, that's great. So now what we want to do is we want to use this loader to load in a object. But before we do that, I'm going to go ahead and get rid of a couple things first. So we don't want this sphere anymore, which means we don't need the geometry associated with it. We don't need the material associated with it, and we don't need the mesh associated with it either. Okay, so that means also at the same time, if we try to save it, it's going to break because we're going to try to rotate this down here. So we're just going to comment that out just for a bit. All right, so now your project should look like this, blank, and if I hit F12, there's no errors. So that's good. All right, so now let's focus on loading the actual object. So we're going to say loader.load, and then we pass in the URL to our bullseye GLTF file. And this happens to be the way Webpack is set to deal with this folder structure. You put your assets inside of static, and if we do that, all we have to do is just reference as if it's in the root. So bullseye.gltf. Okay. After that, then we have our function where we pass in GLTF. And inside of here, we're going to go ahead and say Joule is equal to gltf.scene. Now, notice how we're not specifying let or const or anything first. We're going to do that out here. Let Joule equals null. And this is kind of important because when we're gonna make this animate so it slightly bobs up and down, like as if it's sitting on water or something. And when this function down here runs for a request animation frame for the animation, it's gonna try to load and find that immediately. So we're gonna have to wrap that in an if statement. If it's not null or if it's true, then go ahead and try to then animate it. Because otherwise, if we don't do this right here, the scene will error. So after that, we can then say scene.add gltf.scene. That's how you get it into your scene. So you load it here through the loader, the gltf loader, the URL to it, and then we bind this to Joel is equal to gltf.scene, and then scene.add. Now, of course, we're going to do some more stuff with this, but let's see what happens. Notice how dark it is, and we can't move it. It's not rotating because, again, we took off any type of the spinning rotation effect. We don't have orbit controls enabled, so I can't move it, but we can see it's really dark. And that's because this default lighting is very weak. So if we change that to 1, for instance, all right, that's a little better. Let's also add an ambient light so that we can really brighten up the scene as well. So const is going to be ambient light. And we're going to use white, so it's 0xFFF, and then we're going to change this intensity to 1 as well. Obviously, it's not going to work until we add it to the scene. So let's save that. There we go. So now it's nice, full, bright, and white, essentially. Okay, so at the same time, I am going to refer real quickly back to this style CSS. We're going to give this a different background color. And it's going to be like a really light beige, essentially. So I'm just going to paste in the RGB code right here. That happens to be this color. All right, it's like right there, if you can see that. And it's 255, 234, 201. So let's save that. And it just helps separate it from the background a little bit. Okay, so now let's switch gears and let's try to position this thing in the original starting position of where we want it to be, essentially. Like when a page first loads. So again, remember, we're going to use dat.gui. We already have our constant GUI set. And we're going to do this inside of the function where we load the gltf file. And so when we do that, all we have to do is go ahead and specify a new folder. So we're going to say const Joel folder equals GUI.add folder. And we'll call it Joel. All right, actually, why was I calling this a Joel? It's because before I was working with a Joel 3D asset, and I haven't updated the actual variable names, so just ignore that. Obviously, we would want to name this something more like target folder or something like that. So I'm going to keep it as is, though, just to make my life a little bit easier. So Joel folder, we're going to add joel.position, and we're going to use X. Then we're going to do a min of -7, a max of 7, and a step of 0.01 like we did before, but this time we're also going to give it a name. So we can also chain on the name method and just give it a position, let's see here, position X. There we go. So now we're going to replicate that a couple times. This is going to be Y, and this is going to be Z. Additionally, I'm going to take these three and we're going to paste them right down here. We're going to do the same thing for rotation as well. So rotation, rotation, and rotation here. This will be rotation as well. There we go. Okay, so we'll save that, and we'll go back to our file, open this up, and we could see our position and rotation. So position right here, if we want to, oh, I'm sorry, we didn't update the X, Y, and Z parts. Let's do that real quick. Y and Z. Okay, that's better. Okay, so now we can move this on the Y-axis. Z, we can rotate it a little bit. All right, so that's really cool. So let's take the Y, let's see, the Y position, and I think we're going to set the rotation Y position. We're going to set this to 1 or so. So when we know where we want it to look or set, Again, we just put joule.rotation.y equals 1. All right, so let's save that. So now that's how it's going to start off, but I want to scale it down too. I don't want it to be this large. So we can also set scale through joule.scale.set. And again, you could add scale as well in the XYZ axis as well down here if you wish. So for the scale though, I'm going to set this at 0.5, 0.5, 0.5 to essentially just decrease the size in half of what it currently is by default. And so there we are. That's where we basically want to start off our scene. Okay, and real quickly, just so we have something to show, I'm going to revert to our index.html. We're going to put a section here underneath our canvas. We're going to put H1 that says bullseye, and then we'll go ahead and copy this, and then we'll say something like gnarly, and then we'll give this a class of animate. And the reason we're giving this a class of animate is because we're going to use this scroll trigger, the scroll trigger to target this element for the scroll trigger target, if you recall what that means essentially. Now we're going to go back to our style CSS and address just the section. And again, I'm just going to paste this in right here, this rule set. There's nothing exciting happening, just a big large font size and replacing stuff right in the center. So if we save it now, we should see it show up behind here. Isn't that cool? It's not the most exciting thing because, you know, our bullseye is just fixed in the center. For all anybody else knows, this is just a transparent GIF or PNG or something like that. But we want this thing to move. Maybe we want it to move, like when we get right here, we want it to move over to the right-hand side and rotate and scale up in size. How would we do that? Well, first, let's try to get this oriented roughly in the position of where we want it to be down here. So the position X, for instance, we can push this maybe right here, and then the rotation Y, or would it be X? Let me see. Nope. Let's change that back to 0. Unfortunately, there's no undo. There we go. Now we'll have it face this, but we'll also use scale to make it larger. Okay, so we can note these values roughly right here. We want to change the position X and the rotation Y value so that it's over here when we start to do the animation. So now let's go ahead and define a timeline. So our timeline, our green sock timeline, can be also defined right inside of here. So we're going to say const TL equals gsap.timeline, scroll trigger. The trigger property, let's go ahead and zoom up here, is going to be section.animate. So we're targeting that specifically. And then we're going to say start is going to be top bottom. So this means that when we start to scroll down, it's going to immediately move that target. It's going to create our animation. And you can adjust that with these other properties, which we've talked about already, with the other potential values rather. So end is going to be bottom center. Let's turn on the markers, and let's make this a scrub-based animation. Now, we just only defined it on an instance of the timeline right here. So now we can call the timeline to method. So we'll do tl.to, and we're going to say joule.position, and we only want to change X. It was around 1.72 or so, if you recall. In fact, if I go back and we look, we'll see that, unfortunately, I must have saved and it refreshed or something. But anyways, it's right around, I guess I put 1.42 or 72? Yeah, 1.72, which would be like right around here. And then we also want to change the rotation as well. So what we'll do is also copy this, chain another one onto it. This is going to be rotation, and this is going to be on the y-axis, and a value of around negative 1.33 works. But we want this to occur at the same time as this animation. So if you remember, we put a comma and then a less than sign. All right, and then let's just see what this looks like before we continue on. Oh yeah, All right, so we scroll down, and they're right there. Okay, so we want it to scale up in size as well. So we can go ahead and take this, copy that, paste it, and this is going to be scale. And then we're going to reference the X, and this is going to be 1, not -1, sorry. And then we're going to do a Y and a Z right here. Great. So now if we go back, look how big it is. Oh yeah, that is very, very, very cool. But we can make it even more smooth and fluid-like. So what I did is I wanted it to bob up and down. I wasn't sure what the math would look like that, or would look for that, because when it comes to creating, you know, these type of like circular paths or something that bobs up and down, there's a little bit of math involved, and I'm not good at math. So I asked ChatGPT to help me come up with code that would make a Three.js element or an object, a 3D object, move up and down as if it were on an ocean. And it knocked it out of the park the first time, which is surprising because sometimes you have to really work with it a little bit in order for it to get to work. So I'm going to go ahead and paste in some of the code, and we'll talk about it just briefly. So outside of our tick right here, our tick function, we're going to put in a few properties. The base Y is the base Y position of the model. The amplitude of the bobbing, adjust as needed, and then the frequency of the bobbing, you can adjust as needed as well. So when you play with these values right here, it'll affect what the animation looks like. And then additionally, we just wrap everything in an if statement. If Joule exists, remember, Joule is by default specified as null up here. But if it exists, and because this tick function runs all the time, once it does exist, this then will start to animate it. So what we'll do is just delete this entirely. We're going to say if Joule, and we're going to say, at this point, I'm just going to paste in the code that it gave me. So it's just defining a time property, performance now times 0.001, and then it has this position Y on the Joule, base Y, math.sin, time times frequency times amplitude, which is defined up here. And so if we save it and we go back, look at that nice subtle animation that it's giving us. And it still works while you're scrolling, which is very cool. Okay, so just to show you what would happen if we tried to run that without the if statement, look at that. Cannot read properties of null. So it's saying essentially at runtime it doesn't exist because it takes some time to load up that asset. So that's why you wrap it in an if statement. Okay, another thing that I wanted to do real quickly is, remember we did import Linus. We haven't actually imported the code. So if you go to the Linus GitHub page, and this is a code that's been featured throughout almost every lesson here. I'm not saying you always have to use Linus, by the way, but it's just for these type of scroll type of animations. It's really, especially scrub-based animation, it's a very nice effect. So now we can go ahead and just paste that in. And did I not update that? Oh, okay, there it is. So now it just feels and looks so much more smoother since it has that nice smooth locomotive scroll occurring. And look at that. So now you basically have the ability to take a 3D object or multiple objects. You can change them in any way. You can rotate them based on scroll. You can move them over to reveal part of an interface that you've already constructed in the HTML and CSS. So that's a very typical, one of the most prominent use cases for Three.js when you're building out these interactive advanced front ends, or these landing pages essentially. It gives you a lot of really cool, possibilities when you do this overlay effect or underlay, or however you want to situate the z-index. There's a lot of other things that you can do though with Three.js in terms of shaders, as they're called. And shaders, that's a topic that I'm just not comfortable enough trying to talk about and teach. But if you've ever seen, for instance, on some websites that have like a photograph and you hover over it and it starts to liquefy and do like a wave flag, or it does some type of really crazy thing, you're not sure how to explain it, that's typically through Three.js, specifically speaking, the shaders. And again, I would suggest taking that course if you really want to get into shaders much more. So at this point, now that we've basically created this cool sort of effect, we know how to move objects now with GSAP. We'll go ahead and have a little challenge here, and then we'll conclude this particular chapter of the course, and then we're going to get into the final project where we kind of just bring most of everything we learned together into one cohesive project.